Hey class, Mr. Houston here, back to talk to you more about right triangles.
I'm sitting right here too.
The Mr. Brooks is right here too, just in
Don't
case
have to
anyone was
exclude me
concerned.
just because you don't like me.
7.1 was all about the Pythagorean theorem, and 7.2 is all about the converse of the Pythagorean theorem. If we remember back to chapters 2 or 3, when we talked about converse, inverse, all those good things, a converse is just when we kind of flip the if and then statements around. So before, if the square or the sum of the square of the legs is equal to the square of the hypotenuse, it's a right triangle. We're just kind of flipping that around and trying to prove if a triangle is right or not. Okay, so add this to your theorem postulate page, Theorem 7.2, the converse. And we're going to jump right in and try to determine if, tell whether the given triangle is a right triangle. Okay, the biggest side is always going to be your hypotenuse. And in these triangles you can kind of see the right angle would be here, opposite that would be there. Maybe in like example B we can't tell which one is the hypotenuse. Again, it's always the largest number there. Okay, so we're just going to do our a squared plus b squared equals c squared. C again is always the hypotenuse. Always, always, always. So 9 and 15 are our a and b. C is 3 radical 34. 9 squared is 81. 15 squared is 225. 3 radical 34 squared would be 3 radical 34 times 3 radical 34. Together the 3's would make 9. The radical 34's, that would cancel out the radicals, giving us just 34. So 9 times 34 is 306. 81 plus 225 is 306. So if 306 equals 306, this would be considered a right triangle. Okay, let's try that with example B. Again, a squared plus b squared equals c squared. Again, if we don't know which one is c, it's always the largest number. The hypotenuse has to be the largest number. So our legs are 22 and 14. 22 squared is 484. 14 squared is 196. 26 squared is 676. 196 plus 484 is 680. And 680 does not equal 676, so this is not a right triangle. Okay, so that's how we use Pythagorean theorem to determine if it's a right triangle. Now, some of you may be asking, well, what if we want to classify the triangle as acute or obtuse or right? Well, there's a way to do that using the Pythagorean theorem. Theorem 7.3 and 7.4, if c squared is less than a squared plus b squared, then the triangle is acute. So if you're on your paper, I would maybe highlight, circle, underline. If c squared is greater than a squared plus b squared, then the triangle is obtuse. Okay? So let's just kind of put that into action here. Just one example. Again, your biggest friend here, the past two lessons has been a squared plus b squared equals c squared. Again, if we don't know, the largest number is always c. So 4.3 and 5.2 are our legs. 6.1 would be our hypotenuse. 4.3 squared is 18.49. Please write all the numbers down. Don't try to shorten it for any reason. 5.2 squared is 27.04. And 6.1 squared is 37.21. Oops, 37.21. Add those two together, we have 18.49 plus 27.04 45.53, and that is greater than 37.21. So remember, this is my a squared plus b squared, and this is my c squared. So the legs are greater than the hypotenuse. So when that occurs, that falls into this category right here. So this triangle that we would have would be an acute triangle. Okay, had the sign been the other way around, it would be obtuse. All right, so that's just a crash course in the converse of the Pythagorean theorem. Hopefully we are starting to understand a squared plus b squared equals c squared. That's all I have for you today. Bring your questions to class, and we will see you then.